Perfect. Awesome. Hey, everybody. My name is Cam, and together with my colleague Bing Yi, I'm going to be introducing the Landmark Retrieval Challenge for this year. So this year we held the fourth edition of the Landmark Retrieval Challenge. There were two things that were new about this year. As was the case with the recognition challenge, we collected the data in a more fair way. Um, and we switched this year's challenge to be a coding competition instead of just a model submission competition. The challenge also ended just 10 days ago with a runtime of 7 weeks. And like Tobias said earlier, we weren't able to provide prize money this year, but still saw really strong participation with 263 teams. Since this landmark challenge was closely related to the recognition challenge, lots of teams participated on both, and there was a lot of strong overlap of the top performers between the two. Before we talk about more details, let me take a step back and introduce the general challenge itself. The problem formulation is that of traditional image retrieval. So given an image of a landmark, retrieve images of the same landmark. We use the standard mean average precision metric to score the solutions, and we cap the ranked lists at top 100. One major change this year was the challenge format. So last year, participants had to upload a TensorFlow model that extracted global features from an image. These models were scored using a hard-coded image retrieval pipeline on Kaggle. And while this leveled the playing field and put an emphasis on efficient methods, lots of folks felt that this was overly restrictive. They couldn't use local features or sophisticated re-ranking or lots of other techniques. And it also forced participants to upload TensorFlow models, which not everyone was familiar with. So this year, we decided to change the format to a code competition, just like in recognition. So how exactly did this work? Participants were asked to develop their own retrieval algorithms in a Kaggle notebook. That way they could use those libraries, frameworks, and supplemental data of their choice. And importantly, they could take advantage of those more advanced and diverse approaches. The code to retrieve these matching images was then rerun on Kaggle's servers directly. And Kaggle's Python runtime provides pretty much all the common Python libraries needed for machine learning and computer vision. And participants are free to import, or were free to import any pre-trained models or upload models that they had trained themselves. Kaggle provided ample resources for sophisticated methods, including image retrieval with global, local features, ransack, etc. So the challenge data this year, as is the case every year, was split into two parts. We had data that was available for the development process and data that was developed or available for the evaluation process. The development data first consists of a training set, so no need to download it if you didn't want to train locally. It was already on Kaggle, but we had 1.5 million images available from GLDV2 clean. The index set, which has 76,000 images from GLDV2 index, and a test set, which just has around 1,000 landmark queries from GLDV2 test. Note that this data is not used in any way for score computation, same as in the recognition challenge. But for the evaluation data, we had an index set, which consisted of 100,000 images freshly mined from Wikimedia. There's no image overlap in this data set with GLDV2, but there is a partial class overlap with GLDV2 train. And we had two test sets, one which is used for the scoring of the public leaderboard, and one which is used for the scoring of the private leaderboard revealed only at the end of the competition. About 33% of the landmark images were used for the public, and the remainder were used for the private test set. And this evaluation data, both the index set and the two test sets, were what we had to remine this year or re-download in order to sample them according to the relevant scores that Zhu was talking about earlier. And with that, I think I'm going to hand it over to Bingyi to talk about some of the challenge results.
Thanks, Cam. So now let's introduce the metrics and also probably the conclusion of the landmark retrieval challenge this year. So this slide shows the final results on the private dataset of the top 10 teams with their MAP score. So congratulations again to all the winning teams in the retrieval challenge. From the table, we can see the top 10 teams all achieve a MAP over 48%. And for the teams highlighted in orange, they are going to bring their presentations and solutions to us in the following session. Next one, please. So this is a histogram of the MAP score for all the participating teams of this year compared with last year. So we can see last year, a lot of the teams just resubmit the baseline we shared. So there is a spark in the orange bar. And for this year, the MAP score is much more spread out because this year we switched to a code competition from the model upload method. So that involves more diversity. So all the top 24 teams achieved a MAP over 40% for this year's challenge. Next one, please. So here we also plot the precision versus the rank of the retrieved image for this year and last year for the top 10 teams. So here, to explain this in a little bit more detail, so when we're cutting off the age of the retrieved image at the rank 50, for example, so the mean precision here means the fraction of the corrected retrieved image with the rank which is lower or equal to 50. So that's how we plot this PR curve. And then we notice that on the left side, this year's PR curve for the top 10 teams, they're not very informative. All the 10 curves are very close to each other. So we also noticed that the MAP of the top winning team this year of our first place is 10% higher than the 10th place. But last year, the first place team has a MAP of over 25% higher than the 10th place. So that's a little surprising because this year we had a code submission which should have more diversity, but that may be because a lot of the teams were able to take advantage of last year's solution and improve from there. So it becomes more challenging since the improve space is much limited. So the next one, please. So we also applied other two alternative metrics to the top 10 team solution besides the MAP score. We also have the mean position here. Here, the mean position means the mean position of the first relevant image. So which means we hope this number to be lower the better. And we also have the mean precision at rank 10. So we noticed from this table, all these numbers are quite consistent across all the three metrics, and our winning teams were able to achieve top score in all these three metrics. So we cannot wait to see their solutions. So now let's conclude the Landmark Retrieval Challenge this year. So we had a great time setting it up. We hope you guys had as much fun as us when competing. And we're happy to see very strong participation, even though there is no cash prize this year. We also changed the challenge format to the code competition to be in line with the recognition challenge. And hopefully this allows more diversity in the solutions. And this year, we were able to collect the data in a fair way. So which means we will select the landmark images by just stratifying the demographic attributes. And we hope that also reduces the bias in the solutions, since now the solutions need to be applicable to all kinds, like a wider range of the landmarks. So right now we are open for the Q&A session. And while we were taking questions, can I also ask the winning team to prepare for their presentation in the following session? So now we're happy to take questions.
Maybe in the interest of time, Bohyung can start setting up the slides for the speakers, and if there are questions, people can